Okay, so we'll finish up the chapter 2 notes. Problem 16, I want us to solve each equation. Part A, the absolute value of 4x plus 3 equals 27. So we always get two equations when we go to apply the definition. One of them is going to be just like the absolute value bars aren't even there. The other one, you gotta you have the equation u equals negative a. So u equals a and u equals negative a. Make sure that you lose the absolute value bars. Also, 4x equals 24. 4x equals negative 30. 4x equals 24 means that x equals 6. 4x equals negative 30 means that x is equal to negative 15 halves. Both of them are going to be solutions. Okay, we can check these real quick. If x is 6, 4 times 6 is 24 plus 3 is 27. The absolute value of 27 is 27. 27 equals 27. If x equals negative 15 halves times 4, we get negative 30. Plus 3, we get negative 27. The absolute value of negative 27 is 27. Okay, 27 equals 27 is true. Part B, solve for x. Okay, if I subtract 3 and then divide by 2, then the absolute value of negative 3x minus 2 equals 5. Now I'm ready to get my two equations. So the first one is like the absolute value bars aren't even there. The second one, throw a negative on the right. So negative 3x minus 2 equals 5, and negative 3x minus 2 equals negative 5. Add 2 to both sides. So negative 3x equals 7, x equals negative 7/3. Add 2 over here. Negative 3x equals negative 3, x equals 1. Both of those are going to be solutions. Part C, the absolute value of 8x minus 11 equals negative 7. No solutions to this one. I don't even have to check if I don't want, because the absolute value of a number is never going to be a negative. Okay, so how many positives are equal to negative 7? None of them. None of them are equal to negative 7. So at no point will we ever have a true statement with x. No solutions. Part D, 15x minus 5, the absolute value equals the absolute value of 35 minus 5x. Okay, so 15x minus 5 equals 35 minus 5x. Add 5x to both sides, subtract 5 from both sides. Add 5 to both sides. And we get 20x equals 40. X equals 2. 15x minus 5 equals negative the quantity. 35 minus 5x. Negative the quantity 35 minus 5x means I have negative 35 plus 5x. Add 5x, or subtract 5x, add 5 to both sides. And I get 10x equals negative 30. X equals negative 3 is the solution. By the way, the definition for removing the absolute value bars is exactly the same as it was when I do have absolute value bars only on one side. One of them is going to be like the equation, like the absolute value bars aren't even there. The other one is going to be where I throw a negative on the right. U equals negative a. Okay, so same deal here. U equals a. U equals negative a. Problem 17, solve the inequality and write your own answer using set builder notation or interval notation. Okay, so the first one, I've got a less than sign. Less than means I'll be writing the word and. So the absolute value of 5x minus 7 less than 2. Okay, well that means that negative 2 is less than 5x minus 7 less than 2. If I split this inequality, negative 2 less than 5x minus 7, and 5x minus 7 less than 2. If I add 7 to both sides, 5x less than 5 less than 5x, and 5x less than 9. And I add 7 to both sides. Divide by 5 on both sides here. 5 over 5 is 1. 1 less than x, and x less than 9/5. So the set of all x such that x is greater than 1, or less than negative 5, and less than 9/5 is the answer. Okay. Part B, get the absolute value of 2x minus 7 greater than or equal to 15. 2x minus 7 greater than or equal to 15, or 2x minus 7 less than or equal to negative 15. One of them is going to be like, and by the way, here's another thing about losing the absolute value notation. Whenever the sign is facing away from the number or from the absolute value, you're going to have negative a less than u less than a. Whenever it's facing towards the absolute value bars, then it's switched on us. One of them is going to be u is greater than a, or u is less than or equal to negative a. Okay, so one of these I want to I would just like pretend like the absolute value bars aren't even there. The other one, flip the sign and throw a negative on the right there. So 2x minus 7 greater than or equal to 15, or 2x minus 7 less than or equal to negative 15. Add 7 to both sides. 2x greater than or equal to 22, or 2x less than or equal to negative 8. Divide by 2 on both sides. X greater than or equal to 11, or x less than or equal to negative 4. Okay. So on my answer here, I need the set of all x such that x is less than or equal to negative 4, or x greater than or equal to 11. One thing about the case where there's an or statement versus an and statement is that or needs to be written throughout the entire calculation, including the answer. I'll have or, this group of numbers or this other group of numbers. And is different. And it goes away when I go to write that down in 3-part form. Okay. Next one, the absolute value of 9x plus 1 minus 2 greater than 8. Okay, so if I add 2 to both sides, an absolute value of 9z plus 1 greater than 10. So or is the key word, or because I've got a greater than sign, greater than. 9z greater than 10, or 9z greater than, or 9z plus 1 less than negative 10. So if I subtract 1 from both sides, 9z greater than 9, or 9z less than negative 11. Divide by 9 on both sides. Z is greater than 1, or z is less than negative 11/9. So my answer, set of all z such that z less than negative 11/9, or z greater than 1. Here's another one here. If I add 10 and then divide by 3, 3 times the absolute value of 5 minus x greater than or equal to 9, divided by 3. Absolute value of 5 minus x less than or equal to 3. And So let's see here. If the sign is facing away from the absolute value. So I know that and is going to be a key word here. My three-part inequality, 5 minus x less than or equal to 3 greater than or equal to negative 3. Okay, if I subtract 5 throughout the three parts, negative 3 minus 5 is negative 8. 5 minus x minus 5 is negative x. 3 minus 5 is negative 2. Multiply throughout the three parts by 1, and you get 8 greater than x greater than or equal to 2. So the answer here, the set of all x such that x is greater than or equal to 2 and less than or equal to 8. Okay. Of course, one thing that I'm doing here is I'm paying attention to which way the sign is facing. Okay, if the sign is facing towards the absolute value bars, I'll be writing or. If it's facing away from the absolute value bars, then I'm not writing or at all. I'm writing and. Okay, and is going to be in the answer. And means I've got three parts though to the inequality. Okay, so that's it for the homework in section 2. Be sure to look at the homework for me.